My name is Clara. I'm from Teralytics, which is a startup. We do mobility data and insights from telco data. So today I'm going to tell you all about it. I do product management there. My boss is actually also there. He's the co-founder of the company. He was the one who was sitting in the telco center and like sort of dark, cold, and data center to actually code 6 years ago. So I'm going to give you an intro of what Teralytics does, how we do what we do. I'm going to introduce you to the product that we have called Matrix. And then I'm going to give you a demo to show how you can solve some transit use cases with it. And then some of the next steps in case you're interested to use more of it. So we're a technology company inherently. We're a 70 people company based in Zurich. 6 years old. We work with telcos around the world, take their cell phone signals, and then convert it into trip level data. What we do is we take the signal, we estimate the location of which the device is at, determine whether something is moving versus being stationary, and then we say this is a trip, right? A lot of the transit questions comes down to, are you taking a subway, are you taking rideshare? Inherently, the 100% of the picture is what we're providing here. We are a transit-oriented company. A lot of our clients are city governments, transit operators, a lot of the major destinations around the world. A little bit more about how we do what we do. So starting from the left there, you have the mobile network data, which is what we deploy inside a telco data center. We take the cell signals, and then we apply our technology stack on it to do the location estimation, moving stationary detection that I just mentioned, which is petabytes of data in real time. In the US, we generally see about 150 data points per person per day. So that's how we translate the signal. There's about 60 million devices that we see in the US currently. As you can see, it's a very representative sample size. What we do then is to translate them into transit insights. So what is the trip volume? What is the mode of transit that people took? Is it subway? Is it rideshare? What is the travel time, trip purpose, demographics, and routes that people took? So I'm just going to show you how the data looks like a little bit. Oops. So this is what we call flying dot video, which is showing you kind of the raw data. I mean, we translate it into a trip already. Every flying dot is a trip that is happening in New York. You can see that that's around 2 p.m. right there. You can see some of the major origin and destinations that are flying around. So it's like we like showing these in conferences because it looks very flashy and everything. And then you're going to tell me, this is not useful. It's just flashy, right? So I'm going to show you the product next. So actually, before I jump there, I think I see a bit of frowns in the audience. So chairs, and I totally get that, right? Like, this is so creepy, and there's a lot of articles recently that's about like location data privacy. We being inherently a Zurich-based company, and our first market is actually in Germany. We're actually GDPR compliant from the get-go, and you'll be like, how does that work? Because when we export the data out, it's never going to be about your data. It's always going to be about a group of people. So without the same number of people going from A to B, we're never going to give that data to our end client. And that's also one of the virtue of us working within the telco center. And I can talk a lot more about it if you're interested to know more. So next, I'm going to jump into the demo pretty soon. This is our product matrix, which is kind of have a data set underlying the platform. And there's a visualization platform where you can filter, subset, and extract the data that you need and do pretty simple analysis with it. A lot of our the projects that we have done in the past is in the transit service operator world, where we work with railway companies across the world, rideshare companies, trying to understand how do you plan the route or like adjust your schedule accordingly. We work with city and planning governments who are interested in equity issues. Where are the underserved neighborhoods? And we also work with major destinations such as like, you know, the Disneyland, the parks, the downtown sort of like neighborhoods, to help them understand where are there like less visitors than usual, and therefore how can they improve sort of where should I put events, and like, you know, how can I attract more visitors. So I'm going to make it hopefully a bit more interesting by seeing if you know the answers to these questions. So we have a lot of transit operators who ask us, you know, where should I put my next route? Where should I run service? So I'm going to show you a demo of New York next. What is the transit route to run service between midnight to 4 a.m., assuming you have you have a bus just sitting there? Like, where should I put it? What is that? L train. All right. We're going to look at that next. The second question is for like city planning governments, you know, who commutes to work really early, who wakes up really early to go to work. It's probably taking them a long time. How long do they have to travel to get there? And the third is like more of, you know, I know a lot of transit techies through biking. You know, I often think about where should I bike, you know, in the morning. So I'm like avoiding the crowd. So the third question is kind of personal, you know, when should I visit the park, and which park should I visit to avoid the crowds? So with your answers formulating in your mind, I'm going to jump to the demo. Can you see my screen well? Is it too small? All right. So this is our platform. What you're seeing here is just New York City data. We actually have nationwide data, but like just to keep it nimble, as you can see, there are already a lot of flows. Each flow here is representing the origin, like the trip volume, like between origin and destinations. This is currently in census tract level. I should make it a little less to make it more visible. So you can see some of the major flows. On the left-hand side, we basically see all the filters that we can put on top of it, where you have, in here we're showing 2018, like all the trips that happens within that year within New York City. We split it by quarter, actually every 6 months, weekday, weekend, and then we split it by like sort of 24 hours. We also have sort of trip purpose here. So this is like our pretty standard stuff. Like I said, like we also do mode of transit. So like I can talk more about it afterwards if you're interested. So going back to the first question, midnight to 4 a.m., like where should I put the shuttle, right? So let's do weekday because it's easier or like more predictable, I guess more consistent. So I'm narrowing down to my hour of day to midnight to 4 a.m. And now I see that these are my top flows. I can also see top origin and destinations. So if I select these, knowing that these are the same origin going to similar destinations, and I select those. Do you know what that route is? So it's going from apparently Koreatown to around Flushing, so the Corona area. Interestingly, if I sort of now remove it, some of the interesting stuff that I found as well is that if I look at top destinations, this thing pops up, and it is South Bronx. So a lot of people are going to South Bronx in that area, maybe to work as well. Hunts Point, sorry. And if I go to weekend, what's your guess? Actually, pretty predictable, I think. It's I think the L train would probably come up at some point, but if I go to weekend, and again I look at the top flows, and again I select these top flows, There's this meatpacking sort of between, I think, 14th to 16th Street, like post 8th Avenue, going back to FIDI and the Midtown area. That's how a lot of our clients are like clicking through this and like sort of finding insights through that way as well. So the second question, which is who is commuting to work early? So I'm gonna make it a little smaller. Actually, South Bronx did come up as, Hunts Point did come up as one of the examples. Since we're here at intersection, I'm gonna select Hudson Yards as the example. So I can, besides selecting flows like I've shown before, you can also select locations. Can narrow down to just looking at that location. And now just clearing some of my filters. If I select people going to work, and I actually only want to look at people who come to Hudson Yards to work, let's say. Oh, that's why the flow is looking weird, because I'm looking at just midnight to 4 a.m. And now you see that actually like most people like go to work between like 4 to 10 a.m. to Hudson Yards. If I now look at who's coming really early, let's say between 4 to 6, you see that this is approximately how far they have to travel. You can actually also export the data to look at what that curve looks like, which I actually did a Tableau analysis, but I think you get the idea from here. And if I move to 4 to 6, now you see the distance is a little shorter. My hypothesis is like it's probably construction workers who have to come here early, or maybe they work near the Penn Station area. And now if I move to the 8 to 10 period, now they're traveling really close. Now they are from Midtown, they're from a little bit of Washington Heights, downtown Brooklyn. The more interesting thing too is like if I switch to people that are going out from Hudson Yards to work. And now they all work in financial district. So that's a second case, which is how far do people travel based on where they live and how far they have to go. The third one is on the park case. So anyone here know, is Central Park more popular or is Prospect Park more popular as a destination? Yeah, from an absolute volume perspective, right? So if I now select Central Park, let me expand back. Probably not a lot of people going work there. You can see that this is the hourly pattern. So, which is more of the like later pattern. If I now move to Prospect Park, so actually like I think this one I might have to move to my Tableau analysis. So you can actually export all these things. And actually I'm only interested in trips that are going into Central Park. And then I can export those trips. And then I did the same with Prospect Park. And I can again download the CSV from there. So now I'm gonna jump back to my slide. All right, so I did all that. What happens is, this is how the patterns look like. So I actually have like Prospect Park as more of a late night park, and I have like Central Park more of a morning park. What you're looking at there is, up there is Prospect Park, and then down there is Central Park. And you see sort of the morning peak, where it's like Prospect Park see more of the afternoon peak. You also see that like winter clearly was a dip that people stop going there a little bit. And so I think to answer the question, if you're biking in the morning, you want to avoid a crowd, go to Prospect Park. You want to bike in the afternoon, then go to Central Park. All right, so yeah, just to sum up, like I kind of walked through like three sort of like pretty, like kind of like New York trivia questions, but a lot of those things are kind of what our clients ask us as well. So from a transit service operator, we get a lot of questions of where should I offer services, when should I offer services. From a planning department perspective, who are the transit population that needs help and where are they commuting to and from. And I have the downtown sort of districts like parks and destinations who are like thinking about how do I attract more visitors? When should I do that marathon, for example? So we are a startup. Product is about 6 years old, but we're constantly improving on it. We would love your feedback on our product, and feel free to talk to both of us after the event. We do have additional features on mode of transit and like some of the other stuff on demographics and travel time that we do. So if you're interested in that, we're also happy to chat. We, as part of the product management team, we are doing user research. This tool is currently not free, but we are doing user research where we're giving a trial license if you have a project that you want to collaborate on with us. Also, like, some of the stuff that like Mary and like Luke like presented, I can already see a lot of collaboration opportunities. So if you're working on something like that, we'd love to work together. This is my contact information on the right bottom. But like I said, Georg Poser, my boss and co-founder there, we're both happy to chat. All right. Yeah, so actually, one of the biggest strength of our data is that it does represent, I guess, as representative as it could be in representing all segments, because it actually, when you think about your phone, right, it doesn't have to be a smartphone to have a telco subscription, which means that even for people who are using flip phones or like prepaid plans, they would also have a phone. So like, which those people, a lot of location data that's being collected today actually only have like people with like very heavy digital like footprint, which is people who use a lot of apps, or like they use like smartphones only, maybe it's only iOS. So like our data is actually quite comprehensively representing all segments. Yep. So like in there, you see sort of to work and to home. What we do is, again, like one of the strengths of telco data is that you see where the person dwells at night and also the second most dwelled location that they have. So using that location, we can determine that that is going to home or going to work. Yep. So that is one of the ways that actually come to our advantage when we detect like people who are taking subway, because when they lose a signal, we see like all these signals like crashing out a subway station when they get there. But it is true that like it kind of breaks out from time to time. When you think about 150 signals per day, it's about 10 to 15 minutes per signal. So like losing a signal, it's still like you will still see that person like after they come out of the ground. So from detecting an origin destination perspective, we're still pretty good. All right.